All right, welcome in Python programming. We are going to build your foundation piece by piece. So pay close attention. Let's begin. First things first, let's get this quote from the creator of Python, Guido van Rossum, locked into our brains. This isn't just some nice-sounding phrase. It is the single most important principle we're going to cover. Your job isn't just to write code a machine can understand. No, your job is to write code that other people can understand. This one idea, this philosophy, is what separates a good programmer from a great one. You know, learning to program is a lot like learning any other language. There's grammar, there are rules, and before you can write poetry, you have to know how to form a sentence. These rules, they are not optional. They are the bedrock of everything we're about to do. So, where do we start? Well, we start by making the computer talk. How do we see if our code is actually working? For that, we have a fundamental, absolutely essential tool, the print statement. The print function is basically your window into what the program is thinking. You tell it what you want it to say by putting some text, inside quotes, right there between the parentheses. Now, this command you see here, print, hello world, it's a rite of passage. It's the first thing almost every programmer ever writes. Why? Because it gives you instant feedback. It's the computer saying, yep, I heard you, message received. Okay, let's talk about something that is not for the computer at all. This is for you. Or more specifically, it's for the you that's going to look back at this code 6 months from now with zero memory of what you were trying to do. And trust me, that will happen. So what is a comment? It's a note. It's a message to your future self or to anyone else reading your code. The computer sees it and just skips right over it. It couldn't care less. Its whole purpose is to explain your intent. The code will always show you how something is done, but a good comment, a professional comment, explains why. And the syntax couldn't be simpler. You just use a hashtag or a pound sign, whatever you want to call it. See it right there? Anything on the line after that symbol is a comment. It's an explanation. This is a non-negotiable habit for writing clean code. Start doing it now. All right, so we can make the computer talk to us, and we can leave notes for ourselves. But what about making the computer remember things? How do we hold on to a piece of information so we can use it again later? Well, that's where variables come into play. Okay, here's the formal definition. A variable is a name that references data in memory. Sounds a little academic, right? Let's make it way simpler. This is the best way to think about it, I promise. Imagine a cardboard box. You can put something inside it, say the number 42. Then you take a marker and write a label on the outside of the box, something like user score. Now, anytime you need the number 42, you don't have to remember the number itself. You just look for the box with the user score label. It's that simple. And here's how you do it. The name of your box, your variable, goes on the left, then an equal sign. Then the value, the thing you're putting in the box, goes on the right. This is called assignment. Now listen carefully. That equal sign is not what you know from math class. It doesn't mean is equal to, it's an action. It means assign this value to this variable. It means put the thing on the right into the box labeled on the left. Now you can't just name your boxes whatever you want. There are rules. They must start with a letter or an underscore, never a number. They are also case-sensitive, which is a big one. As you can see, a box labeled age with a lowercase a is a totally different box from one labeled age with a capital A. And the professional standard, the way we do things, is snake case. All lowercase letters with words separated by an underscore. It just makes things easier to read. So we have our labeled boxes, our variables. Fantastic. We can store stuff in them, but what kind of stuff can we put in there? This brings us to a really important idea. Data types, right? Can we put text in there? How about numbers or numbers with decimals? Can we store a whole list of items in one box? The answer is yes to all of that. But Python has to know what kind of data it's working with, so it knows what it can do with it. Let's just run through the basics here. A string, that's short for string, is just text. An int, for integer, is a whole number. A float is a number with a decimal point. A list is a collection of things you can change later, kind of like a shopping list. A tuple is a collection you can't change. It's locked in. And a dict, or dictionary, is for storing related info in pairs, like a name and a phone number. Now, this is a big concept, so listen up. The difference between mutable and immutable. Mutable means changeable. A list is mutable. You can add things to it, you can take things away.
Immutable means it cannot be changed. It's set in stone. A tuple is immutable. Once you create it, that's it. It's a crucial difference to understand as you move forward.
Let's circle back to strings for a moment. Most of the time, they're pretty straightforward. But what if you need to put, say, a quotation mark inside your string of text? Or what if you want to force the text to a new line? For that, we need special instructions. We need escape sequences. And the way we give these special instructions is with a backslash. Just think of that backslash as a secret signal to Python. It's like you're saying, hey, pay attention. The character that's coming next isn't normal, it's special. So, as you can see, a backslash followed by an N tells Python, start a new line here. Simple, right? It's a handy little trick.
And here's exactly how it works. Look at step 1. We've got our print command with that little \n tucked right in the middle of the text. Now look at the result. Python sees that secret signal, that \n, and it knows exactly what to do. Create a line break. So in step 3, that's what we get. 2 separate lines of text. Powerful stuff from just 2 little characters.
You now have the fundamental building blocks. You've got the grammar. But knowing the words isn't enough. You have to know the style, the proper etiquette that separates clean, professional code from a messy, amateur project. These are the golden rules. And look at that. We've come full circle, right back to where we started. All of these rules, all of these conventions, they serve one and only one purpose: making your code readable, making it understandable for other humans. Rule 1. 4 spaces for indentation. Not 3, not 5, and never ever use the tab key. In Python, indentation isn't just for making things look nice, it's part of the syntax. It defines the structure of your code. 4 spaces is the universal standard. This is not up for debate. Rule 2. Keep your lines of code to a maximum of 79 characters. This isn't just to avoid scrolling sideways, it's a constraint that forces you to write better, clearer code. It encourages you to break down complex thoughts into smaller, more manageable pieces. This is not a suggestion. So there you have it. You've got the grammar, you've got the rules, you've got the tools. The rest? Well, the rest is up to you. What problems are you going to solve? What are you going to build? What story will you write? Class dismissed.